Where will KCL and KVL fail?
There is a transformer in the circuit. Whether in this circuit KCL and KVL is applicable, there is a diode in the circuit, and in this circuit whether KCL and KVL is applicable. To understand this, let us watch the video fully. Hello all, welcome to our YouTube channel. Today we will discuss where KCL and KVL fails. Earlier in our videos, we have seen KCL and KVL is applicable to all passive elements like resistance, capacitance, and inductor. Whether KCL and KVL is applicable to semiconductor diodes or any other power electronic diodes, switches, and MOSFETs. Yes, KCL and KVL is definitely applicable for power electronics or any semiconductor switches, but only thing is we have to realize them in two kinds of operations. Means if there is a switch, then you have to convert this. The switch can have two states: one is on and one is zero. So if semiconductor switches are there in circuit, you have to realize it in two states, during on state and during off state. So for example, if this circuit was given, whether KCL and KVL applicability you want to, yeah, if you want to apply KCL and KVL for this circuit, then you have to realize this circuit in two states. One is during off state and another one during off state. So you just have to convert this circuit diagram as shown below. For on state, so for on state the circuit will be closed, and this is how the circuit looks for on state. For off state, just you have to replace the same circuit, same switch with open circuit. This is how you have to derive two circuits and you have to apply KCL and KVL accordingly. Okay, where and all KCL and KVL will fail? KCL and KVL will fail for high frequency circuits where high frequency waves are used in that circuits. Those circuits KCL and KVL will definitely fail. For example, a circuit using microwave elements. Circuit using microwave elements will definitely fail KCL and KVL applicability. Why? Because in high frequency electric field circuits, there is definitely a chance of displacement current to be considered for those circuits. Okay, before understanding what is displacement current, first we'll understand what are the types of current. Two types of current, one is conduction current and second one is displacement current. Most of us are familiar with this current, conduction current. What is conduction current? Conduction current is majorly because of flow of electrons in the circuit. Means if there is a battery connected to a load draws a current in a wire, and this is fully conduction current. This is because of only flow of electrons there is a draw of current, and that is called conduction current. That means inside the wire what is happening, if you are connecting a battery, there is a flow of electrons because of electric field applied. Means here this side if it is positive and this side it is negative, and electrons are flowing toward positive and causing a flow of electrons. This is called conduction current, and the current direction will be this direction. This is known current and it is conduction current. And what is this displacement current? We, to understand this displacement current, we'll use a capacitor. For same example, if battery is connected to a capacitor, whether there is a flow of electrons in the circuit? No, because capacitor has insulator medium between its plates, so electrons cannot flow over this insulation medium, and then this is not a closed circuit, so there is a no flow of charge. If the same capacitor, if it is connected to a alternating voltage, Will there be any flow of electrons? Again, here also there is no flow of electrons, but there is a current. And what is this current? This current is called displacement current. How this displacement current is formed is, during positive of cycle, inside the insulation medium, all the negative charges will be accumulated towards positive plate. Means during positive of cycle, this side will be positive and this side will be negative, and here this side will be accumulated with positive charge inside. And during negative of cycle, same circuit will behave like negative on the negative on the first plate and positive on the second plate, and internally there will be positive over the first plate and negative over the second plate. So plates are inside the plates, there is a type of charge movement which is causing a current, and that is called displacement current. Ideally there is no flow of charge, but still there is a type of movement of charge which is causing a current, that is called displacement current. And this displacement current is because of time varying electric field. Whether KCL and KVL is applicable for this kind of circuits, for lower frequency circuit, still KCL is applicable because displacement current will be very minimal, and capacitor can be used only to apply for KVL. But for circuits with high frequency like microwaves, here you cannot find how is the movement of charge, how is this how much amount of displacement current is produced. For this reason, KCL and KVL will fail for high frequency circuit, majorly for frequency greater than microwave frequency. That's about a displacement current. Now, in the beginning we discussed what happens if transformer is connected into the circuit. Whether KCL and KVL is still applicable, that we will understand. A magnetic circuits where magnetically coupled circuits are there, KCL and KVL will fail. We will understand how it will fail. For example, now if you are connecting a AC voltage source to a transformer, and then you are connecting a resistor and inductor. In this circuit, if voltage is applied is V1, because of number of turns N1 and N2 will have different voltage V2, right? V1 is different than V2. Now if you are trying to apply KVL for this loop and again KVL for this loop, which is magnetically coupled with a ratio of N1 into N2. So for this you can explain KVL separately and KCL separately, but if you want to apply both KCL and KVL for the same magnetic circuit, the equations will not hold good and you will not have the same results which you want to get. So that is the reason for magnetic circuits we will not have KCL and KVL applicability. Next important concept where KCL and KVL will fail is during varying temperature circuit. We know that all the passive electrical components depends on temperatures, and even semiconductors also depends on temperature. If temperature is varied, resistance will not be linear, and even capacitor and inductor behavior will also vary for time increasing temperatures. And also power electronic components behaves differently with the time varying. Now if there is a circuit with time varying application, then you cannot consider KCL and KVL for the same temperature zone. You cannot consider KCL and KVL applicability for the same temperature zone. So that is the reason KCL and KVL will not be applicable for temperature varying circuits. So that's it about KCL and KVL applicability. If you like the video, please like, share and subscribe. Thanks for watching.